Deep in the frozen vacuum of space, 13 billion light years from Earth, the James Webb Space Telescope has discovered something impossible: ancient galaxies that shouldn't exist, black holes older than time itself, and signals that suggest our understanding of reality is fundamentally broken. If you're ready to discover the universe's darkest secrets, buckle up, because what I'm about to show you will change everything you thought you knew about the cosmos. We begin. The expansion crisis. Something is terribly wrong with the universe itself. For decades, scientists believed they understood cosmic expansion. The Hubble Space Telescope gave us one measurement. Mathematical models predicted another. Everything fit together like pieces of a cosmic puzzle. Then James Webb looked deeper than anyone had ever looked before, and the puzzle exploded. The universe is expanding at two completely different speeds. Think of a balloon being inflated where the top stretches twice as fast as the bottom. This should be impossible. Physics demands uniform expansion across all of space. When Webb measured expansion using distance-fit variable stars, it got one number. When calculated using cosmic microwave background radiation, it got a completely different number. After studying over 1,000 stars across 5 galaxies, the contradiction remains. Scientists call this the Hubble tension, but that name doesn't capture the true horror. Either our models are completely broken, or there's an unknown force tearing reality apart. Dark energy might be behaving in ways we never imagined, creating cosmic rifts in space-time itself. As lead researcher Adam Rees put it, what remains is the exciting possibility that we have fundamentally misunderstood the universe. If our understanding of cosmic expansion is wrong, then our calculations about the universe's age, size, and fate are all suspect. But this was only the beginning. The impossible galaxies. When Webb pointed toward an empty patch of sky near the Big Dipper, astronomers expected baby galaxies. Instead, they found 6 massive star systems that shouldn't exist. These galactic giants contain nearly as many stars as our Milky Way, but they formed when the universe was only 3% of its current age. Picture growing a full-sized oak tree in 3 months. That's what these galaxies accomplished on a cosmic scale. Each monster galaxy contains between 10 billion and 100 billion stars. To reach such sizes, they would need to form hundreds of stars every year for hundreds of millions of years. Our Milky Way creates only 2 new stars annually. The team nicknamed them universe breakers because they threaten to break our understanding of cosmic structure formation. According to every simulation, matter in the early universe should have clumped together slowly over billions of years. These 6 galaxies throw that timeline out the window. They suggest the early universe was capable of complexity that cosmologists never imagined possible. The naked black hole. Deep in the early universe, Webb discovered something that defies every theory of black hole formation. Quasar is a supermassive black hole with virtually no galaxy surrounding it. It's naked, drifting through space without the billions of stars that normally accompany such massive objects. This cosmic wanderer contains 50 million times the mass of our Sun, compressed into a region smaller than our solar system. What makes this truly disturbing is the timing. Quasar exists just 600 million years after the Big Bang. Traditional black hole formation requires the death of massive stars, which takes far longer than 600 million years. 3 theories attempt to explain its existence, each more unsettling than the last. physics should allow. Third, and most disturbing, quasar might be a primordial black hole created in the universe's first seconds during vital fluctuations immediately after the Big Bang. If true, it means quasar has been lurking in the cosmic darkness since the very beginning, waiting 13 billion years for us to find it. And it's not alone. Webb has identified hundreds of similar objects throughout the early universe. Black holes before stars. Scientists assumed supermassive black holes formed after the first stars died, but Webb found evidence of supermassive black holes existing when the universe was barely 400 million years old, far too early. A radical theory proposes the solution. What if black holes, not stars, were the first significant sources of light in the universe? Primordial black holes would have formed through extreme density fluctuations in the primordial soup less than 5 seconds after the Big Bang. Picture the early university, Earth, as a violently boiling pot where some regions became so dense they collapsed directly into black holes. The evidence supports this bizarre scenario. Many bright objects in the early universe appear point-like rather than extended, suggesting compact sources rather than distributed star formation. If this theory is correct, primordial black holes were fueling the universe's first gas clouds, lighting up the cosmos while simultaneously growing larger. These monsters were sitting in the dark for hundreds of millions of years, waiting for food, and they might still be out there today, wandering through our galaxy, ancient relics that predate every star we can see. The rogue planet. Signals. Webb has identified over 500 free-floating planets in the Orion Nebula that don't orbit any star. These Jupiter-sized worlds have been ejected from their solar systems and now drift through the cold emptiness of space. What makes them truly bizarre is that many travel in pairs, orbiting each other. Scientists call them Jupiter Massive Binary Objects, or JUMBOS. The mystery deepened when radio telescopes detected something unprecedented. Several jumbos are emitting powerful radio signals with patterns never seen from planets before. These aren't typical emissions. They're producing gigahertz frequency radio bursts thousands of times higher than FM radio. On Earth, signals at these frequencies come from technology or extremely energetic phenomena like pulsars and quasars. The radio emissions appear linked to their binary nature. When two massive objects orbit each other, they create complex gravitational interactions that generate powerful magnetic fields and electrical currents. The jumbos are essentially giant electrical generators powered by their orbital dance. If hundreds of these paired worlds exist in one nebula, there could be billions scattered throughout our galaxy. Each represents a failed solar system, a cosmic tragedy where gravitational chaos ejected planets into eternal darkness. The Hell planet's impossible atmosphere. Pleiades 5 can create orbits at stars so closely that it completes a full year in just 18 Earth hours. Surface temperatures reach over 4,000 degrees Fahrenheit, hot enough to melt copper. By every rule of physics, this world should have lost its atmosphere billions of years ago. Webb discovered the impossible. This Hell planet not only has an atmosphere, but it's made of materials that shouldn't exist as gases at such extreme temperatures. The atmosphere is rich in carbon monoxide and carbon dioxide, creating a thick blanket around a world that should be airless as Mercury. This atmospheric circulation creates one of the most extreme weather systems ever discovered. Imagine winds howling at thousands of miles per hour, carrying vaporized rock and metal from the day side to the night side, where these materials crust itself is boiling. Intense heat and tidal forces are cooking the planet's interior, causing carbon-rich materials deep underground to vaporize and escape through volcanic outgassing. The entire world has become a massive distillation apparatus, operating under conditions that push physics to its limits. The ancient visitor, Comet 2, I/Borisov, is racing through our solar system, and it's older than Earth, the Sun, and everything we call home. Webb's analysis revealed this interstellar visitor is approximately 7 billion years old, making it 3 billion years older than our entire solar system. This cosmic wanderer has been drifting through interstellar space since before the Sun existed. It predates Earth, Mars, Jupiter, and every planet in our neighborhood. It formed around a star that lived and died billions of years before our Sun existed. It survived the death of its parent star, possibly a violent supernova that destroyed its original solar system and sent it wandering through the galaxy. For 3 billion years, it traveled through the cosmic deep, a frozen time capsule carrying chemical signatures from an ancient epoch. Statistical models suggest dozens or hundreds of these cosmic time travelers should be crossing our neighborhood at any moment. Each represents a fragment of a destroyed world, carrying information about stellar systems that existed when the universe was young. The coordinated spin. In what may be Webb's most mind-bending discovery, astronomers found evidence that galaxies separated by millions of light years are rotating in coordinated patterns. When analyzing 263 galaxies from Webb's Deep Survey, they found something impossible. Galaxies too distant to influence each other gravitationally are spinning in similar directions. Think of discovering that every windmill across an entire continent is turning in exactly the same direction, even though there's no wind pattern that could coordinate their motion. Two explanations exist, and both are deeply unsettling. First, the universe was born rotating. If the Big Bang itself had angular momentum, it could have imprinted a preferred rotational direction on all cosmic structure. This aligns with black hole cosmology, a theory suggesting our entire observable universe might be the interior of a massive black hole within a larger parent universe. Second, if the universe wasn't born rotating, then existing theories about cosmic evolution are fundamentally incomplete. Some unknown force must be operating on scales larger than anything scientists have considered. A rotating universe would have different physical properties than the static cosmos described by standard models. Space and time themselves might have preferred directions, and if our universe is spinning inside a larger structure, it implies reality extends far beyond the observable cosmos. We might be living inside just one component of an incomprehensibly vast multiverse. The fast-feeding phantom, hidden among thousands of X-ray sources, Webb identified a supermassive black hole breaking fundamental rules about feeding rates. The object designated LID 568 is consuming matter at 40 times its theoretical limit. Every black hole has an Eddington limit, the maximum rate it can consume matter without radiation pressure blowing away its food supply. Think of trying to drink from a fire hose. Beyond a certain flow rate, the pressure prevents further consumption. LID 568 is somehow drinking from 40 fire hoses simultaneously. At such extreme accretion rates, this black hole could have gained most of its mass in a single feeding episode. The object exists just 1.5 billion years after the Big Bang. This fast-feeding phantom could explain how supermassive black holes reached enormous sizes so quickly. Instead of slow, steady growth over billions of years, they underwent brief but intense feeding episodes that increased their masses by factors of 10 or more. The physics remains poorly understood. The black hole has somehow stabilized the process, despite radiation pressures that should blow everything away. The Vanishing World. In what researchers call the most significant Webb finding to date, the telescope detected a giant planet orbiting Alpha Centauri H8, our closest sun-like star, only to lose track of it completely during follow-up observations. The planet appeared in initial observations as a thermal signature consistent with a Neptune-sized world orbiting within the habitable zone. The discovery would have been groundbreaking, representing the closest potentially habitable planet to Earth ever found. But when astronomers attempted to confirm the detection, the planet simply wasn't there. Several explanations challenge our understanding. The planet might have an extremely elliptical orbit, making it detectable only during brief periods, but such an orbit would be gravitationally unstable. The planet might be surrounded by a variable dust cloud that periodically obscures it, suggesting the Alpha Centauri system is far more active than believed. Most disturbing, the thermal signature might represent something that isn't a planet at all, a previously unknown type of cosmic phenomenon hiding in our nearest stellar neighbor. If a world can appear and disappear in observations of our closest star, what other phenomena might be hiding in plain sight? The sleeping giants. Webb has discovered what researchers call sleeping beauty galaxies, scattered throughout the early universe, massive star systems that mysteriously shut down their star formation when they should have been most active. These cosmic giants contain billions of stars but show no signs of creating new ones, defying every model of galaxy evolution. During this period, the universe was rich with gas and dark matter, creating ideal conditions for rapid star formation. Most galaxies from this era should be blazing with new stars. Instead, Webb found numerous massive galaxies in cosmic hibernation. The Sleeping Beauty nickname comes from their dormant state during what should have been their peak activity. Like the fairy tale princess, these galaxies stopped growing at the height of their development. Several theories attempt to explain this. Supermassive black holes might have heated surrounding gas too hot for star formation, but the timing doesn't match. The galaxies might have consumed their gas so rapidly they ran out of fuel, requiring star formation rates far higher than models predict. Most disturbing, they might have encountered an unknown process that doesn't exist in the modern universe. If massive galaxies could shut down this early, galaxy formation is far more complex and unpredictable than we believed. The universe unveiled the discoveries James Webb has made don't just challenge our understanding of the cosmos, they fundamentally alter what it means to be human in a universe far stranger and more dangerous than we imagined. We thought we understood how galaxies form, how black holes grow, and how the universe expands. Instead, we've discovered space is filled with impossible objects, violent processes, and phenomena operating according to physics we don't comprehend. The universe Webb reveals is not the orderly, predictable cosmos described in textbooks. It's a realm where galaxies can form faster than physics allows, where black holes wander naked through space, and where reality itself might break down under extreme conditions. Perhaps most unsettling is what these discoveries suggest. inside a black hole universe, as evidence increasingly suggests, then we're forever cut off from whatever larger reality contains us. The prevalence of cosmic violence Webb has revealed also affects our survival in space. The universe is filled with wandering black holes, mysterious rogue planets, and stellar catastrophes that can sterilize entire regions of space. But Webb's revelations also offer hope. The universe's capacity for surprise and complexity suggests cosmic evolution might be far richer and more diverse than our models predict. The telescope has revealed we're cosmic infants living in a universe operating according to rules we're only beginning to glimpse. Every strange object Webb discovers represents an opportunity to expand our understanding. Perhaps, most importantly, Webb reminds us that the universe doesn't owe us comprehensibility. Reality operates according to its own logic, following principles that might be fundamentally alien to human intuition. The universe James Webb has revealed is strange, violent, and often incomprehensible, but it's also the only reality we have, and understanding it, no matter how disturbing our understanding, represents a possibility for navigating future events. If these discoveries and subscribe, because Webb is just getting started, and the universe has many more secrets to reveal. The question is, are we ready for what comes next?